Today we are going to discuss about the formation of developmental part of the neural tube. Before understanding the neural tube, we should know the general structure present in the trilemma disc so that it will be easy for us to understand the neural tube. First, see, this is a trilemma disc will be there, right? The trilemma disc, and above there is a ectoderm, below there is a endoderm, and in between there is a mesoderm will be there. And in the mesodermal area, the development, the long process of the notochord will be there, right? And the ectoderm above cavity is the amniotic cavity, and below the endoderm we have secondary yolk sac or yolk sac will be there, right? So now onwards we will see how this from the ectodermal part the neural tube is going to form. Okay, so again before that we should also know that this the cranial end, this is a cranial end, this is a caudal end. Okay, so towards the cranial end we have, this is a procaudal plate. Procaudal plate will be there towards the head side, and towards the caudal, this is a cloacal membrane will be there, which the half of this part is removed and we don't want that one. Okay, so we will remove this half of that part. We don't want this one to discuss now, right? And the central portion we have this side as a primitive node will be there, primitive node or hand sense node through which the procaudal, the notocaudal process is going to form. So, see what is going to happen. What is going to happen in this the new ectoderm? That is what we are going to understand now. See, this is the notochord. This is the notochord. Above the notochord, in the ectoderm part, from the notocaudal primitive node towards the procaudal plate, that portion of the ectoderm is going to become a differentiated and will become thickened part. Okay, the red color zone what you are seeing, it's a part of the ectoderm which is a differentiated, right? Called as a neural plate. What it's called as? It's called as a neural plate. This neural plate central axis, the axis of the embryonic disc will be the craniocaudal axis. A central part of this axis, the cells of the neural plate will have little bit, the funny thing is going to happen that the cells at the center is going to sink downwards. Okay, they are going to sink downwards so that along with the central line there is a groove is going to produce here. Okay, the groove is going to produce, that groove is called as neural groove. What is called as neural groove. That groove along with this central axis is called as neural groove, right? As this depression is going to produce, on either side of the neural groove is an elevated portion. Okay, that elevated portion is called as neural folds, or they are called as neural folds, right? Okay, there are either side of the neural groove, there are two neural folds are there, right? The neural folds are there here. See, this is a normal portion of the ectoderm, okay, which is coming towards, which is the, and this is a developing part of the neural plate. Okay, so neural folds are going to form here, and the cells above the neural folds, which are the junction of the normal ectoderm and the neural folds, that the what you can see the black color line, that area of the neural folds will again get differentiated and they are going to form as a neural primitive neural crest cells, or they are going to form the primitive neural crest cells. Okay, the tendency of this development of neural folds is that they are going to come close together. Okay, the neural tube is going to neural folds, the central cells are going to sink downwards and neural folds are coming very close together. Okay, and you can see that as the neural folds are coming close together, the normal part of the ectoderm also coming close together. Okay, when these neural folds will join with each other, the normal part of the ectoderm is again going to join and complete this surface. Right? As this development is going to happen, there is some funny thing is going to happen. Okay, so what happens? For example, another time once again. So this is ectoderm. Okay, this is the ectoderm, and this side is a procaudal plate. And this is a primitive node will be there, and this portion of the ectoderm in the central axis, cells of the neural plate is going to sink downwards, right? When they are going to sink downwards, in the central line there is a groove is going to produce, and that groove is called as neural groove, right? So either side of the neural groove, that elevated portion is there. Here there is an elevated portion. That elevated portion is called as neural folds. This is clear. Neural groove, neural folds. On the top of this neural folds, the cells present, they get differentiated and they are going to form as a primitive neural crest cells. Okay. The tendency that the neural groove is going to downwards towards the mesoderm, and coming close together, these neural folds will happen. So one thing you have to remember, that the top of the neural crest of the neural folds will come to close together, but the thing is, neural crest will not going to form a part of the neural tube. These top cells will get escaped. Okay, so what happens? Neural folds are come towards, and the top cells of the neural crest, which are the nothing but the neural crest, primitive neural crest, they will get separated and the tube is going to close. Okay, and this is a neural tube, and this side we have the neural crest cells. Now these are called as neural crest cells. So where they present? On the superolateral side of the neural tube. Okay, so this is, and above, as it is going to close the form, and the normal layer of the ectoderm, again it's going to take part in its complete form. Okay, below there is an endoderm, and this side there is a mesoderm. The most important thing what I want to highlight here, see, the neural tube is going to form, and the whole tube is going to join, and the junction of the neural folds will take place at the middle part first, central part first. And the anterior side, that is a cranial side and caudal side, the neural tube is even now it is opened. Okay, so neural crest cells are separated, but anterior side, that's a cranial side, and caudal side, the posterior side, they are opened. That opened area is called as a neuropores. Okay, so anterior neuropore towards the cranial end, and the posterior neuropore at the caudal end. Okay. Later, after joining this neural folds at the center, slowly they are going to close anterior first, then the posterior neuropore later. Okay, so the starting of this neural plate formation will start from the 17th day of the conception, and the closing of this anterior neuropore and the posterior neuropore all be on the 25th and 27th day of the conception. So here is very important thing which I want to highlight here. See, conception on 25th day, that time that some lady may not know she got a pregnancy. Okay, to close this anterior and posterior neuropores, they need a special chemical in their blood, that is a folic acid. 3 to 5 grams of folic acid should be there in the bloodstream. With that fuel of folic acid, these pores are going to close. Suppose she don't know if she is a pregnancy is there, and the folic acid level is lower than the normal, which is required to close the anterior and posterior neuropores, it will lead to a serious problem in the developing embryo, that they don't close or there is abnormality in the closing of anterior and posterior neuropore. If anterior neuropore doesn't close properly, it leads to the anencephaly. The head portion will not be there properly, they won't going to develop properly. And if the posterior neuropore doesn't close properly, there are a lot of varieties of the spina bifida conditions are going to form, like spina bifida occulta, many varieties of spina bifida is going to form. Okay, so and through this, the neural tube, the CNS structures are going to form through the neural crest cells, the PNS is going to form. And in next class we are going to study about how the neural tube is going to form the brain and spinal cord, and what are the derivatives of the neural crest cells, right?